Spanning tree protocol. Spanning tree protocol. But before we get into the spanning tree protocol, I would like to explain you about the trunk negotiation. The trunk negotiation. What is trunk negotiation? To form trunk, the two end of the wire, the device connected to the two ends of the wire, they negotiate, they talk. If one side is auto, the other side is configured as trunk, there is a need for negotiation, you see. Further, there is a protocol, .1Q. Not only that, even if you configure trunk on either side, trunk, whether you configure trunk on either side, there is a need for this protocol, the trunk negotiation protocol. There is a need for the protocol. For what? For marking the VLAN IDs. You see, for example, this computer belongs to VLAN 10. This computer belongs to another VLAN, let's say VLAN 20. Now, whenever A wants to talk to B, the traffic goes to the switch port. Switch port will send it through the trunk port because trunk port is a member of all VLAN. But there is another responsibility of a trunk port. It takes your packet, in that it is going to add the VLAN ID. Who is adding this? Trunk port is adding. Before sending it out via trunk port, the .1Q protocol will insert this in layer 2 header the tag, VLAN tag. The receiving switch, let's say switch 2, reads this VLAN tag It reads the VLAN tag. After reading the VLAN tag, it removes the tag. Switch 2, after knowing, it removes the tag and send the down normal original packet which is sent from A. So this field is only when the switches are handling the packet. When it is sent out to the remote destination, this gets decapsulated. It is removed. Here it is encapsulated. After receiving this tagged traffic, the receiving switch will untag and send only the packet, normal packet, no tags. Without any tag, B will receive it. See, if this tag is not there, switch will not know Switch 2 won't be able to identify the group to which the packet belonged. Switch 2 needs this hint. Switch 2 needs the hint. Switch 2 needs this tag value to decide to which broadcast domain, to which VLAN this packet belongs. This tagging and untagging is done by the same .1q protocol. On the trunk port, you need this trunk negotiation protocol. It is not only used to negotiate and bring the trunk mode operationally, it also tags the value, the VLAN numbers. On the receiving switch, it untags. And now this VLAN is inserted right in layer 2. It's 4 bytes of value. 4 bytes of value is inserted in layer 2 header by this .1q. This .1q is industry standard. Every switch on every vendor uses only .1q. But Cisco also have another protocol to do this job. What job? Adding the VLAN ID to the frame, which is called as inter-switch link. But nowadays it is no more in Cisco switches. Even Cisco have removed it. The reason is, in the production in the real world, you cannot find all switches from Cisco. You will have multi-vendor mixed. In that case, ISL will become a problem. The other switches don't understand ISL. Not only this reason, there is another very important reason, which is this ISL is using 32 bytes. Oh, it's overload. This is only inserting 4 byte, but this is encapsulating 32 bytes. What does that mean by encapsulation? See, in layer 2, it is inserting who? .1q. Whereas this one adds additional layer, which is of 32 byte. Which one? ISL. 32 byte, every packet will get overloaded just to provide 16-bit information. VLAN ID. So, ISL is not really seen in industry, but you should know this difference. Sometimes some may ask you the trunking protocols. What are they? One is ISL, the other one is .1q. .1q is popular industry standard. IEEE 802.1q. So very popular, everyone uses. Whereas inter-switch link, which is a Cisco proprietary, can be used only when you have Cisco switches, can't have multi-vendors. The other problem is just to add VLAN ID, ISL needs 32 bit, 32 byte, not bit, 32 byte, whereas .1 key uses only 4 byte. So ISL will slow down your network by adding too many load. So ISL is not really in use. The other important difference between .1Q and ISL, which many people want to hear from you, is .1Q inserts, ISL encapsulates. .1Q inserts, ISL encapsulates. What does that mean? You want to protect your valuables. You want to protect your gold, silver. You buy one safe box and keep it secretly in your house. That is .1Q. ISL is you cover your entire house with big, tall, and thick iron wall. You want to protect your gold and silver and maybe some land documents. ISL says, okay, no worries. We will put one big compound wall, full made up of iron, and it will be bulletproof, all proof, very strong. The entire house fully fortified. That is ISL. .1Q is gold and silver and document only that much. No, don't worry. Safe box is of different size. Go to SP Road in Bangalore. There is one big street only for safe box. Secret sections will be inside that safe box, which no one can, even CID officers cannot find. That is .1Q. .1Q is cost effective, isn't it? All right. Did you get the difference between these two trunking protocols? Hmm. Spanning tree protocol. Spanning tree protocol. Spinning, spanning, or say சுற்றி வருதல். Spanning. Lifespan. What does it mean, lifespan? பிறந்ததிலிருந்து இருக்கிற வரைக்கும். From the time of birth till that minute of death. Physical death, physical birth and physical death. That is what called as a lifespan of a human. Whatever, any animal, any organization, any organism, from the time it is born to the time it dies, we call it as one life cycle. That cycle, that one round, spanning tree. Span is nothing but going around. Here, a tree is going around. Tree. This protocol is named a spanning tree with a very important meaning in it. Very important reason is there behind naming this a spanning tree. Let's say you are new to a place, you are here. And you want to go somewhere here. You want to go somewhere here. Now you started from here. Let's say between this and this, 15 kilometers. And you are new to this place. You start from here. You go following the road. No Google Map, nothing with you, so you just follow the road. The road goes like this. And then there is one thin line going. And there is another thick line going. You are thinking you are going here, but you are coming down here. You are thinking you are going towards this destination. But the problem is you did not take this small thin road thinking that it will not reach there. You just followed that big road only. And you have come back to the same place where you started. Ayyo, the. This is where you started. How can this be avoided? Someone should span around before you. Someone should have gone like this and saw, oh, there is a chance of loop. We have to stop people looping. So they have to put one tree here. They should put the tree blocking the road so that no one will come back to the same place where they started. If they keep coming back to the same place where they started, they will never go to the destination, no? They will never go to the destination. 15 kilometers, you cannot track the direction, okay? You don't have a compass like what Columbus had earlier. Nowadays, no one knows what compass is. Compass, geometry box. That is what we think is compass. But there was another compass showing direction. We don't use that one. And we have all this roads, zigzag roads, uneven zigzags. So you will think that you are going to the destination, but you will be coming back to the same place where you started if the road here is not locked. This should be blocked. Then you will not come back. The blocking by putting the tree is important to avoid looping. Avoid what? Rounding, spanning, looping, looping. To avoid to avoid looping, blocking is important. Spanning tree protocol avoids loop in layer 2 network, in layer 2 LAN. Loops are very easy to occur. To prevent loop, spanning tree protocol blocks some part of network so that packet will not loop. Packet will go and reach the destination, not simply looping and consuming the bandwidth. Looping is not simple problem, you know. See what will happen. Like me, if everyone is looping, thinking going to Perambur, if they are looping from Nungambakam to whatever the road, Mount Road, and coming back again to Nungambakam, again to Mount Road, again to Nungambakam, if all loop, what will happen? Traffic jam only will happen. Because if everyone goes to the destination on time, road will be free. If all are looping, they time after time, new traffic will be coming. School children looping, office going looping, Velavati looping, all looping. And there won't be any place for now to move. The traffic will be jammed. Full traffic jam. Exactly happens in the network also if loop occurs. But this never happens because by default, spanning tree is enabled. STP is enabled. It is very likely to have a loop in layer 2, but that never happens. How? Spanning tree protocol is enabled, and spanning tree protocol, before the loop occurs, knows that there is going to be a loop, senses that there is going to be a loop, and blocks wherever it is appropriate to block in order to prevent the loop. I'm going to explain this in detail. By now, what you should have been knowing is, what you should know is, there is a protocol to prevent layer 2 loops, and the name of the protocol is spanning tree protocol. And how it blocks is, sorry, how it avoids loop is by blocking. This is what you should have been, you should know by now. You should know that there is a chance of layer 2 loops. To prevent this loop, spanning tree protocol is a protocol that is enabled by default. That is why we are not having loops. And it prevents this loop by blocking some path. Is that well understood? Deeper. You see, we have switch. And I connect green wire and purple wire like this. Why am I connecting two wire? I connected two wire between the switch 1 and switch 2 for high availability. High availability. You see, we have more than one bike in our home. Sometimes even two bikes are not enough for one person. We don't know when which will not work. Three bikes sometimes we buy and keep. Why? During the rainy season, that axis never starts. During the sunny season, Yamaha never starts. So we need another third one. That is what called as redundant. இது இல்லையா அது ஏதாவது ஒன்று இருக்கணும் இல்ல எப்படி ஆபீஸ் போகுது so we buy more than one bike redundancy high availability that is what called as high availability not simply available highly available இது இல்லைன்னா கூட அது இருக்குங்க see A wants to talk to B now we all know A needs to know the MAC address of B. In order to communicate, they need MAC address of the destination device in the LAN. Tell me how A will know the MAC address of B, Sarona. How A will know the MAC address of B? A needs to know the MAC address of B. How it will learn MAC address of B? Now, A will send a layer 2 broadcast. Layer 2 broadcast. That is what ARP uses. Address resolution protocol do what? Layer 2 broadcast. What does that mean? This computer will send a packet from the source address AAA, but the destination address will be all F. How many F? 12F, isn't it? Saruna, 12F. That is the destination. That is what we call it as layer 2 broadcast address. What is layer 2 broadcast address? All F. All bits, all hexa bits are F. Then it is layer 2 broadcast. Now, when this ARP request hits the switch wants to send the packet to all now because it is broadcast address. It wants to send it to all. So a copy goes here and also here. And if you have many more computers, it will go to everyone. It goes to everyone because it is a broadcast. Now the packet that is going here, hitting this switch will also reading this destination will broadcast again. So that broadcast takes one U-turn and comes back. It also goes here, but it also comes back here. Whatever comes back, because it has got FFF, again it will take one U-turn and go everywhere, including these computers. Not only that, this packet which was going, that will also take a U-turn because it's a layer 2 broadcast and come back. Again, it will take another U-turn. After some time, it will be like this. Bidirectional loop. Bidirectional loop, and it will consume the whole bandwidth. There won't be any bandwidth left for any packet to go. This one broadcast will go and consume the entire bandwidth between these two switches and block and bring down the network. It will bring down the network. Loop is bad. But this problem started because of what? Me adding 2 wires. If I add only 1 wire, no problem. There is no chance of loop. If I had only 1 wire, will there be a loop? No. There won't be any loop. If I had only 1 wire, there will not be any loop. Not possible. But when I add another wire just for redundancy's sake, I added, but it is reflecting in loop. It has created loop. See? When you have more than one link, when you have redundant paths, whenever you have high available paths, loop is very common in layer 2. Now, to prevent this loop, spanning tree protocol will choose one port and block it. So that loop can be avoided. Now you see the broadcast is coming. It goes this way, this way, this way. Because there is a block, it won't go. It goes this way, this way. Again, it is because it's a broadcast, it will go to everywhere, but it will not come down. It won't come down because there's a block. Loop is prevented by blocking one of the port. You have 4 ports. 1, 2, 3, 4. Just by blocking this one port, you have prevented loop. Now, who blocked it? If I block manually, when this link goes down, I need to go and unblock. That will take a long time, you see. Sometimes you won't be there in office when this link goes down. That is why you need this protocol, spanning tree protocol. Spanning tree protocol will identify that there is 2 link. Spanning tree protocol will identify that there is a chance of loop. Spanning tree protocol will decide where to block. Spanning tree protocol by blocking makes this link standby. This is the active link, the only link which is available for communication. But when this active link goes down, by unblocking, by automatic unblocking, this will become active. Even when you are sleeping at home, this will happen. You no need to come down to office to make it active. Automatic. Spanning tree will decide to block where to block is taken. Decision is taken by spanning tree. Not only that, when the active link goes down, it makes the standby standby into active by unblocking. This is automatic. And now let's say this is unblocked and this is active. And now this broken link comes back again. What will happen? Again, this will become active and this will go standby automatically. Who does that? Spanning tree does that. And you don't need to even enable the spanning tree. It is enabled by default. Whatever I have explained so far is not after you configured. Even if you don't configure, this all will happen. You want to see? Let me show you. Spanning tree protocol will not be blocking any of this port because it knows that there is no redundant path between these 2 switch. Spanning tree protocol knows it. How it knows it? Spanning tree protocol will be sending a tiny packet called BPDU. It will be sending a tiny packet called Bridge Protocol Data Unit. Bridge Data Unit. This is a tiny packet which will be talking about from which switch it is coming, from which port it is coming, what is the spanning tree cost, all the stuff. So now the BPDUs are going between these 2 switch and there is no loop. Right? BPDU goes from this switch And BPD goes from this switch. Switch 1 knows that this is coming from switch 0. Switch 0 knows that this is coming from switch 1. And they know that there is no loop. But when I have another wire, BPDU goes this way and this way. And the BPDU goes this way is received and it is forwarded down here. And switch 1 receives its own BPDU. Switch 1 is receiving like this its own BPDU. அப்படியா லூப்பா சரி சரி நான் பார்த்துக்கிறேன். That is what spanning tree says. Oh, like that. I understand. There is a chance of loop. So by sending the BPDU only, spanning tree protocol will sense, will identify the loop even before our packet goes. This block happens to prevent the loop. This link is made standby to prevent the loop by STP. It is all because of the BPDU that is going beforehand. When I have written a link, the BPDU that is sent will be coming back that alerts the switch 1 that spanning tree should go and do its job. Both the switch will be in an alert mode. Now there is no chance of loop, so spanning tree will not block. But the moment I connect another wire, you see what happens. Out of this 4 port, 1 port will be red. See this port color. Here this tube turned green, and this thing, the below one, 02, is still blocking. It is not turning green. Why? Because that is blocking. Let me show you that. I'm going to shoot 0, 0, and I'm going to say show spanning tree. Look at this. F02 is BLK. BLK means what? It is not forwarding. Forwarding means it will have FWD. It's blocking. It will be an alternate port, standby port. Show spanning tree is the command. You see, did I do any configuration for this? No. Even before you configure something, even not even a host name, as soon as you connect the wire, the BPDUs will be running. So be careful about this BPDU stuff. Don't miss this BPDU. You should talk about BPDU whenever someone is asking you about spanning tree. Yeah, don't forget. BPDUs or the one alerts spanning tree that there is a chance of loop. You need to go and block 1 port. The spanning tree will block 1 of this port out of this 4 ports. So no traffic will be sent and received on this F02. F02 link is a standby link. Did you all understand? All right. What are we going to see next in spanning tree protocol is how this particular port is blocking. Why this particular port is blocking? Why not those other 3 ports? Why not F01 of switch 1? Why it should be F0 2 option 0? Is there any selection criteria? Is there any procedure in finding a blocking port? Yes. There is a step steps involved in finding the blocking port, which we are going to see in our next class. So this is not chumma selecting one port to be a blocking port. It has got a reason to say why I'm blocking this port, not the other ports. Even though these are all dynamic, automatic, you no need to learn this, but still we learn it so that these are all automatic. Then why are we learning? In case if you don't like F02 blocking, you need to know why F02 is blocking so that I can go and change that Y and make the other port blocking. You understand? That is it. So we learn it so that we can have a customized output whenever we need.